Right, so we are looking at SNS, the SNS service, and where we finished off the last day was I started talking about filtering of the messages between the SNS service and your subscribers. So, so that the subscribers only received messages that they're interested in or are relevant to them. Because what happens usually is that an SNS topic um, can receive different types of messages. You don't tend to have an SNS topic per message type. That's sort of overkill. You have one SNS topic, and then different publishers send different types of messages to that topic. And on the subscriber side, then often subscribers are only interested in certain messages. So we need to do some filtering. Unfortunately, the SNS service does that for us. If it didn't, then you'd have to do the filtering on the subscriber side, and that would work as well. If the subscriber is a Lambda, you'd have a kind of some sort of condition test at the beginning of the Lambda. No, that would work, but it's inefficient from a cost point of view because you're still paying for the execution of your Lambda. Whereas when we allow SNS to do the filtering, then the Lambda never gets triggered by messages that it's not interested in. So we just need to look at the mechanics of how we do this filtering. The concept is straightforward enough. I know I'm going back over ground from the last day now, but when you're filtering, you can either filter based on the body of the message, or what SNS refers to as attributes of the message. Attributes are separate from the message. They're specified in a separate kind of data structure from the actual body itself. Both the body and these attributes are typically their JSON structures. So they both have key value pairs. Okay. And I was saying the last day that you could think of attributes as sort of metadata about the body of the message. That works in some cases. Sometimes the body of the message is metadata. So it's a bit open-ended really as to what constitutes attributes. And it's very much up to you as the designer as to A, whether you need attributes separate from the message, and B, if you do, then what kind of information do you put into the attributes part of a message as opposed to the body of the message itself. So you can do the filtering anyway, either on the basis of the attributes or on the basis of properties of the body. And in either case, the criteria that you can use are these ones here. Like if the attribute or the message property is a string, then you've got these kind of condition tests that you can do on it. Okay. If the value is a numeric value, you've got these kind of condition tests that you can do. And the third is you can express a filtering criteria, which it just says, if a particular property exists, then let it through. If it doesn't exist, don't let it through. You don't care about the value of the property. You only care about its presence or absence. I'll explain these rather than talking through them. I'll explain them by means of example. So the example which I started on the last day, but I didn't actually work through it because I hadn't deployed it. So the example is this simple architecture here. We're again using the CLI conveniently as our publisher, and we're publishing messages to an SNS topic. And our topic has two subscribers. One is a Lambda, and the other is an SQSQ. And what I'm trying to express here is there is going to be filtering done between the topic and the Lambda subscriber. There isn't going to be any filtering done here. So the SQSQ is going to receive all of the messages Hence, this lambda over here is going to process all of the messages. We don't really care about this part of the architecture. This is the part that we're interested in. How do we express our filter? And it's something that you express, like you attach the filter to this subscription, and you do it at the stack level. And here's the specifics then of the filtering that I want to have done. So, so in this case, we're going to have a message body JSON structure, and we're going to have an attributes JSON structure. And we're going to do the filtering based on the attributes. And I've just kind of arbitrarily decided there's going to be two attributes. One is called user type, and the other is called source. Okay, I just kind of plucked these out of the air. They don't really have to mean anything for the purpose of this demonstration. But I'm saying that if the user type is set to student or lecturer, then that message should be allowed go through to the Lambda. And also, if the source attribute, if its value starts with slack, or if it's, if it's prefix, if the prefix of the value starts with the string slack, then let it true. Okay, so that means if I've got a message and the user type attribute is set to student and the source attribute is set to slack slash plus something else, then let it true. If the user type is set to lecturer and the source part begins with slack plus something else, let it true. Anything else shouldn't get through. So for example, if I have a user type of, let's say, admin, then that message should not get through. If I have a message that has maybe student as the user type, but let's say it has Moodle as the source, that should not get through, and so on and so forth. Yeah, could come up with lots of examples. So that's my filtering policy, if you like. Okay, so let's look at the code then. So as before, we'll just take a quick look at the stack file. We've got a topic, that's our SNS topic. We've got a queue, that's okay. We've got a lambda, and just based on the name, this lambda looks like the lambda that's gonna have, switch back. It's this lambda here, but it's just an ordinary lambda. This is the other lambda, the one that's linked to the queue, just another ordinary lambda. And here's where so I'm adding a subscription to my topic, and I'm subscribing a lambda. So I'm subscribing my first lambda, or I'm making my first lambda a direct subscriber to the topic. And here's where we express our filtering. Let me just bring it all into view. The syntax is quite long-winded now, but you have to live with that. So essentially, it sort of begins here, right? Right. So it's a property. Sorry, it's part of the configuration of the subscription. Yeah, that's where the filtering appears. And the way you kind of read this, some of it is kind of boilerplate. The parts that are not boilerplate are this part here. In fact, I'm just going to stop now for 1 second. I'm going to first of all show you the message that I want to send. Maybe I should have done that first. Okay, so this is my message, which is not really of any interest to us, but there you go anyway. That's the message. And the attributes then, we have to specify that in a separate JSON file. And you have to follow a particular kind of syntax or a particular kind of structure when you're specifying these attributes. So the attribute name, user type, and here's another attribute name, source. That's what we had in our policy. And you've got to describe the attribute here. You're telling me, we're saying obviously what type the attribute is. In our case, they're both strings. So I presume you can have numeric types as well, and maybe Boolean types. And then we specify the actual value. So this looks like I'm setting the user type attribute to student, and I'm setting the source attribute to Slack-CAD, say for Cloud App development. So as it stands, that looks like those attributes, when they're linked to a message, that message will get through my filter because it's satisfying my filtering policy. Okay, go back to how I actually express the filtering then in my code. Yeah, here's where we're doing it. So, this here has to match my attribute name, user type. The value that I'm assigning to it is really a class that comes with the CDK library. All right. And what type of filtering criteria or what filtering criteria am I associating with this attribute? And it's the allow list filtering criteria. Now we know that user type is going to be a string, right? And again, if I switch back to my slides, we said if the attribute type is a string, then there are these various filtering criteria that you can associate, that you can define. So the allow list is one of them. And in the allow list, you essentially specify an array of legitimate values for the string. Yeah. Now, in our particular example, we said that the user type could be the string student or the string lecturer. So that's an example of where I would use the allow list. If I had a long list of valid values for user type, if I had 10 different values that were legitimate and only 2 that were invalid, then I would use the deny list option instead, because I need only specify the 2 invalid values in my deny list. And the deny list, as its name suggests, that is declaring what should not get through the filter. The allow list is specifying what should get through the filter. So I said student and lecturer were the only 2 valid values. So my allow list is set to, it's an array, as you can see from the syntax. Yeah, it's an array, and I'm specifying the actual valid values. So that's how it looks. And here then I'm specifying the criteria associated with the source attribute. And in my slides, I said the source attribute, the value has to begin with the substring Slack. So for that type of condition, we don't use the allow list or the deny list. We use the match prefix criteria. And I'm saying essentially here, it has to begin with look at the right one. Oh yeah, okay. My slides are slightly different from here now. Yeah, I'm going to leave it as it actually. I'm saying Moodle or Slack or let me see now, sorry. Okay, Moodle or Slack. So my slides were actually out, or were my slides out? Did I say that in the slides? I should have really said, I should have said here begins with slat or mool. Okay, so the slides are slightly incorrect. Oh, will I correct it? Maybe I should just correct it here. Let's just get rid of that. Now I'm going to have to do a CDK deploy again. It should be quick enough though. Okay, we'll let that work away. So that's it really. That's how I've expressed my filtering, and I'm associating the filtering with the subscription of the Lambda function as a subscriber. Now I have another subscription here. I'm subscribing the SQSQ to the topic, but I'm not defining any filtering for that. Okay, I had some filtering here, but I've commented it out. That's okay. So everything gets delivered to the SQSQ. And the rest then is just where I link up the second Lambda with the SQSQ. That's all that's happening there. And I'm outputting the ARN of the topic. So what I'm going to do is I'm going to send some invalid messages, and then eventually I'll send a valid one. And what we'll notice then when we look at the CloudWatch logs of our first Lambda, it will only have executed once really. Okay, so I go into message. Okay, so I go user one. And in terms of the attributes, I'm going to set this to, let's say, admin. So that means user one will not get through. That message will not get through. And let's send the message. So you can see here, I need to specify the message attributes and the actual message itself. Okay, it's two separate JSON files. Wrong topic, I guess. Let's find the topic. Let's send the second message. Call this user two. On the attributes side, we'll set this back to student. But let's say we change this to now there's something popping up in front of me here. I can put it to, let's say, email. Let's send that message. And eventually we'll send a valid message. So user 3. And my attributes, I'll have student and that. So I've sent 3 messages, but look at my architecture. The filter is going to prevent the first 2 from getting through. So when I look at the CloudWatch logs of my Lambda, hopefully, it will only show that it has been triggered once for the user 3 message. Yeah. Let's confirm that. Now there's 2 log streams here. One log stream is for the Lambda that's subscribed directly to the SNS topic. The other log stream is for the Lambda that's linked to the queue. And in that Lambda, in the second Lambda, we should see that all 3 messages were actually processed by it. Now, I'm not doing anything in those Lambdas, just console logging the messages. Yeah, so I didn't look at the Lambdas, but there's no real need to. So, which is which? So this is the Lambda that's a direct subscriber. So that's the one that should only have received 1 message. And we can see kind of from the log stream that it has actually only been executed once. And again, if I blow this up, let's see, where's the message? Yeah, you can see the message there is for user 3. Now, as well, so this is a console log of the event, console log of the event that's passed to my Lambda, yeah, and because it's it's processing it's linked or it's triggered by an SNS topic, then we talked about all of this before, right? Technically it receives a batch of messages, but I explained to you that it never receives a batch. For every single message that's published to an SNS topic, your Lambda is triggered for every single one. SNS does not do any batching. Still, as I explained before to you, I think it's probably a legacy of SNS. It looks like our Lambda receives a batch of messages because you can see records here is an array, but there's never going to be more than 1 entry in this array. So anyway, we can see the message obviously, but the attributes are also available to us, and you can see them down here, right? So the attributes are made available to you in the message that's passed from SNS to your Lambda subscriber. And the attributes were provided by the publisher. The publisher in my case was the CLI. So if you needed to, you can get access to the attributes within your Lambda if you needed to. Maybe they impact on the way you process the message. But what I've also kind of proven now is that this Lambda never received the first two messages. Okay, there's no log stream for them. Hence, the Lambda was never triggered by them. Whereas if we look at the other Lambda, the one that's linked to the SQSQ, which is this one here, and we can see it was triggered once, it was triggered a second time, and it was triggered a third time. Yeah. And similarly, you see the attributes if you needed to. Yeah, we can see the attributes there. And indeed, which one was it? Oh yeah, the user type was admin. Okay, I hope that all makes sense to you. I just pause to allow a question if there is any question. No? Okay. So what we've shown is how to define the filtering. We do it in the stack file. And we have demonstrated just attribute-based filtering. Okay, the screenshots there, just excerpts from the code. That's just a screenshot showing you where the attributes can be found in the actual message. I've shown you that. Okay, the second type of filtering is where you filter based on the actual body of the message itself. Hence we call it body-based filtering. And the body is a JSON structure, just like the attributes are a JSON structure. But in the case of body filtering, you're focused on values of particular properties of the body. You're ignoring the attributes. You could probably combine them. You can do a combination of body and attribute-based filtering, but we'll take them separately. I'm saying it's the same filtering criteria that are available to you. So it's string filtering, numeric filtering, and the exists filtering. And in this case, our little demo is very similar to what you're doing in the lab. And in fact, you'll be doing this you'll be implementing this filtering in the last section of the lab. So as you know, in the lab, okay, we have the AWS CLI over here on the left. It's uploading images to our S3 bucket. The S3 service is publishing messages to an SNS topic, essentially telling the message essentially says, there has been a state change in the S3 bucket, as in a new image has been uploaded or something has been modified. S3 then, or sorry, SNS then, what does it do? It publishes the message or passes the messages onto an SQSQ, but we want to do filtering of the messages. And for simplicity's sake, I'm defining the filtering policy here. The filtering is just going to say, if the name of the file that was uploaded to S3, if the name begins with the prefix image, then let that message pass through to SQS. If the file name begins with anything else, then don't let it go through to SQS. So it's going to be another example of a match prefix filter, where we're prefixing based on the name of the file that was uploaded to S3. Because, I don't know if we did that in the lab or not, but the message that's published by S3 to SNS, that message body includes lots of information about the state change. And in our case, state change is a new file. And the S3 message will include in the body the name of the file. Okay, so we just need to find where is that name, where does it appear in the S3 message, so we can express our filter around that. Okay, so and sorry, and so we've got a lambda over here then. That's just a normal consumer of our SQSQ. Now, the only place we are going to get an understanding of, like what we need to know is what is the structure of the message that's sent by S3 to SNS. We need to know that structure because that's how we are going to define our filter. We're going to define our filter based on that kind of JSON structure. But the only place I can find out about, well, one place that I can find out about the structure of the S3 message is way over here inside my Lambda. The problem though is that the message that the Lambda receives is the SQS message. And admittedly, within that SQS message, buried within it is the SNS message. And within the SNS message is where the S3 message is. So when we are doing console logging here, we need to drill down in and pick out eventually the actual S3 message. And so what I'm showing you here is a screenshot of the console log of the event that's received by my Lambda on the extreme right. And it's a consumer for a SQSQ. So as we know from before, there is this records property, and it's an array because we know that SQS does batching, so the array makes sense here. So potentially this could be an array of multiple messages, and in our case, they would all be S3 state change messages. All right. And within any one message, so if you like from here, from this way down to here, I guess, that's it, an entire SQS message. The body of that message is our SNS message. I'm kind of saying that over here, right? But we need to parse that and console log it. And when I do that, this is what I see. So what we're now looking at is the messages that are passed between SNS and SQS. If I go back again, so in that screenshot that I just showed you there now, it's showing me the messages that are passed from here to here. And that's where we want to express our filtering. We want to express it on the basis of those messages. So this is the message. This is the message body that we want to do our filtering on. And I'm showing you that within this object here, there is a property called S3. That would make sense because the SNS message comes from an S3 publisher. This S3 property, its value is an object. One of the keys within it is a property called object. The value for that is another object, and within that there is a key called key, and the value assigned to that is the name of the file. So it's this property here of my message body that I want to express my filtering criteria on. So I've got to tell SNS that go look for the records property, then go look for S3, then go look for object, then go look for key, and then do the filtering based on the value assigned to that key property, the property called key. But I've got to describe this structure to SNS so that it can, because it's actually doing the filtering. So it needs to essentially find this property here and decide, should I let this message through or not? Clearly, SNS doesn't know anything about, S3 message structures. We've got to tell it that. So that's what I'm showing you here now. Okay. So this is just this is the topic, new image topic. I'm adding a subscription to it. It's an SQS subscriber in this case. That's correct according to my architecture. And, I'm not going to step through this line by line, but what I'm going to highlight to you is, see, I'm telling it here, look, there's a records maybe if I underline it, there's a records property at the outer bounds of my message structure. Within that, there's an S3 property. Within that, there's an object property. Within that, there's a key property. And finally, then I'm expressing my filtering criteria on this key property. And it's a match prefix type filtering condition, which we saw before. And I'm just saying, look, the value assigned to the key property, which we know is going to be the name of the file, it has to begin with image. In other words, my file name has to begin with image. Otherwise, I don't want the message to be passed on to the SQS queue. Yeah, so, well, before I move off it, all this other stuff over here, it's very kind of loud and clumsy kind of syntax, but it's essentially kind of copy and paste, because the value associated with S3, and we'll start at the right top, the value that we assign to records, the value that we assign to S3, to object, they're all SNS.filter or policy.policy. They're all the same. Yeah. The only one that's different is this one, which is filter or policy.filter. And the dot filter, when you hit that, now you know that what follows is the actual filtering criteria. I do admit now that the syntax is very long-winded and verbose, but you just cut and paste and do your editing. But you've got to be careful with the editing, because we've got to close off all of these things here, right? So it's very error prone. Essentially what we're closing off here are all of these here. Yeah. So does it work? So I've also deployed this stack. Let's try and wrap up this one now. So look, the stack file is, straightforward. There's a topic, there's a queue, there's a lambda, and eventually there is a subscription with filtering, and that's what I've shown you on the slides. So that's all there, right? Oh yeah, that's okay. That's just I'm just linking up my S3. I'm making S3. What am I doing? I'm making, oh yeah, making S3 an event source kind of for my SNS publishing. You've seen all this in the lab anyway, this code here. Okay, and I've CDK deployed it, and I'm just outputting the S3 bucket because that's what I need to access from the CLI. And to upload an image, and you've done all of this, as I said, in the lab. You've done uploading of images to S3. You've done everything in the lab except the filtering, okay, which you will be doing in the lab from this week and next week. So if I go AWS S3, I wonder, have I got the right? Probably don't actually. I need a bucket name. So I need to change this. Grab that. Paste it in there. So I'm uploading an image and I'm calling it in the bucket. I'm going to call it, if you can read it there, I'm going to call it picture one. If I just pull that over. Okay. And so based on that name, picture1.png. So based on that name, the filter should not allow the message to be passed through to SQS. And I'll upload, I can upload the same image, it doesn't really matter. But in this case, up in S3, I'm going to name it image something. It doesn't really matter. Call it image 2. Now, just as with the other example, I'm uploading 2 images. That means 2 messages are going to be sent from S3 to SNS, but SNS is only going to allow one of those messages to pass on to SQS, and it's going to be the second one. And so when I look at the console log, I look at the CloudWatch logs of my Lambda, which is the consumer to my SQS, it should only be triggered once, and it should only be triggered for the file called image2. Now, because there's a queue and there's batching and there's polling going on, there's going to be a slight delay, but hopefully we'll get there before the end of the lecture. So it looks like it got through. Yeah, so that is run. That's one execution because I have 2 console logs in my Lambda. The first console log is this one here, where I console log the entire event. The second one, I think, is console logging the S3. Let's just see it. Can we make it out? Let's go back to the first one. Tell you what I do. If I try and do a search for image 2, and there we can see, right? So this is the second message. If I try and do a search for picture 1, which was the name of the other one, there shouldn't be any matches. Control F, picture. And you can see there aren't any matches. So there's nothing in this console log or in this log stream for picture one. So picture one never got through. Now, it's kind of as complicated. This filter expression really, I suppose, is as complex as you might get because the message itself is it's a kind of deeply nested data structure, objects within objects within objects. But if you can follow the way I've coded this, then you should be able to follow any type of body filtering um, expression. But as I said, in the lab, if I switch over to there, do a refresh, because I think I published that. You can see here SNS subscription filtering is a new section that I've added just there earlier on today. So you'll be able to replay what I've done just now, shown you just now. Okay, that's it for today. I've just got to do a little bit more on filtering Witchy and a little bit on DynamoDB streams, and that's it. Then really, I'll finished all I need to cover Witchy. So I will be finished lecturing really by next week. And I'll also give you a fairly thorough briefing on the lab-based exam, which I'm hoping to run on the Friday of week 12. But more about that anon. Again, I'll just give you an opportunity to ask any questions that you might have before we wrap up. No? Okay, we'll leave it at that, and I'll talk to you again later. Thanks, bye-bye.